Please pardon my the tear in my paper. There was a bear attack right before I started recording this lesson today. So first of all, do you notice that I know it's being weird. Did you notice that I shortened the assignment already? How do you know that? Yeah, we start at 5, okay? If you don't like that, I just need you to get over it, okay? If you need me to find those other 4 problems, I'll be happy to find them for you and assign them for you. No, you're good? Okay, all right. So let's start with number 5, okay? What do you notice about this problem, first of all? We did it yesterday, right? Not this exact one, but something very similar to this, right? And then we also did it a couple days before that, and then we also did it a couple days before that, right? So, what else do you notice about this problem? There's a lot of boxes, right? A lot of things to fill in. And then there's this A and then B. There are 2 ways to do it, okay? So you know that if I know 2 ways to do something, I'd really like to show you so that you can find the way that suits you best, okay? And well, I was about to say we don't know like what problems we're going to encounter, but I know because I'm assigning the problems. But you don't know what kind of problems you're going to encounter, how they're going to show up. So I'd like you to have different ways to solve it just in case. Is that fair? Okay. How have we talked about solving this in the past? Yeah, logarithmic form, right? So what would it look like if we put it in logarithmic form? Log base 6, 104 equals x, right? That's pretty straightforward, isn't it? How would I solve this now? Put it in the calculator, okay? We'll put it in calculator in a minute. We're just kind of setting up. Oh, okay, let's go ahead and do it now. Let's put it in the calculator now. Go ahead and put that in the calculator. An important thing to remember when you're using your calculator is before you try to use it, you should turn it on. That's typically helpful. Yeah. So everybody please put in log base 6 of 104. Wait 5 seconds. And now tell me the answer. 2.592. Is that correct? Okay. Wait, you know what that reminds me of, right? It reminds me of this. When you and your friends survive a bear attack and celebrate with ice cream. Yeah. And looks like most of you, for the record. Okay, so the other way, here's the other way I want you to know how to solve this problem, okay? Now, we kind of use logarithms to solve it this way, right? Except all we did was take it from exponential form and write it into logarithmic form, right? That's all we did. The other way you can solve it is to actually use logarithms. Because as long as we do something to both sides, the equation should still be true, correct? So what if we took the log of both sides? Well, this would be the log of 6 to the x, and this would be the log of 104. But then we see this, and warning bells go off because we can't have an exponent inside a log, right? So where does it go? So x log of 6 equals the log of 4. Does anyone notice what I'm not saying or what's not written? The base, right? Are we okay with that? That doesn't make us panic anymore, does it? Because we know that that is log base 10, right? We're okay with that, all right? So if I'm trying to solve for x, how do I go about solving for x then? Well, what's log of 6 doing to the x? Multiplying, so how do I get rid of it? So if I'm dividing both sides by log of x, what I end up with is, log of 6, I end up with log of 104 divided by the log of 6, correct? Since you all have your calculators on already, would you go ahead and enter log of 104 divided by log of 6? And then wait 5 seconds. And then tell me the answer. What a coincidence. Oh, that's not a coincidence? No? Okay. So there are 2 ways to do the problem, and I get the same answer either way. Typically, which way do you guys prefer to solve this problem? The first way, right? The A way, because it's easier, a little quicker. Okay? But which way is more correct? Neither. There's not one that's more correct. They're just both correct, right? I'll tell you this right now. This is the way they had to do it in the dark ages, so like 10 years ago, because calculators couldn't do any other base but 10. Remember that? Remember I told you about that? So it couldn't do this problem, right? We can do it now, but this is still a way that is known to do it, so I wanted to show it to you. Okay? If they did it like another way, you would have to know, to do it this way, they would have to know change of base property, right? Do you remember that from when I taught you the other day? Oh, well, let's just go over it now just in case. Okay? Do you remember what it is? If I have log base b of n, what's the change of base property? Can I give you a reminder real quick? What's this called? The base, where's the base usually? Oh, log of b. So guess what's on top? Log of n. So the base goes on the bottom. Do I need to do any examples of that for you? No, you got that, right? Okay. All right, look at 17. This says, use this strategy to generate and sketch the graph of each function. I'm going to walk you through this problem and then tell you something silly. Is that fair? Okay. So how do you think we might rewrite this problem? Well, looking at the example right up here, what did they use? The change of base. Okay. So how would we rewrite this problem? Log of x plus 4 over log of 2. Okay? So, this side of the room, would you guys please put in your calculator log of x plus 4 over log of 2? Okay? That side of the room, would you guys just put straight log base 2 of x plus 4? You got it done? Let me see it real quick. I don't care. Somebody from this side of the room? And then what about somebody from that side of the room? Okay, so I got one from that side. I need one from this side. No, let me see it. In the graph, yeah, it's okay. Yeah, you did. You did. That's all right. I'll just put it in real quick. It's all good. Just keep it here for a moment if you don't mind. So log. Oh, I had to show this to last period, so can I show you something real fast? Okay. Do you see that writing right there where it says log? You could just press Control log. You do not have to type in L-O-G every time. Are you okay with that? You can if you want. I'm just... That's not what I wanted. Second log of x plus 4 over log of 2. Yours just turned off. Of course, right as I'm trying to show them side by side. Come on, you can do it. Come on, you can do it. Calculator. Go, 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 go. Oh no, it's mad. Okay. What's the difference?
Oh, ellipse. 1.
What's the difference in the graph? Nothing. So using change of base formula or entering it like we can, it makes it exactly the same. I just need to make sure you were clear about that. Okay? It does cross somewhere around there and somewhere around there, so it looks something like this, right? Just wanted to make sure that you understood that we can put this straight into the calculator. They used to have to do that, but no matter what you put in, you get the same graph. Okay? Look at number 20. How's 20 different than 17? Oh, it's an inequality. Okay? Well, we're going to use our calculator to help us out with this one again. Okay? So I'm going to add a graph page. Oh. Here's what I'm going to put in. What am I going to put in for my first equation? Because it asked me to rewrite it, right? So what I'm going to put in my first equation is log base 3 of x plus 5. What is that? Well, it's the left side of the equation, right? So what goes in y2? Or f2? Yeah, it's a 2, right? So log base 3 of x plus 5, and then 2. So what do I need to know before I can go on? I need to know where they intersect, don't I? Okay. Menu, analyze, intersection. I want here and here. I can see it, but I want to make it a little clearer, so I'm going to move it up here. Okay. All right, I'm going to transfer that graph here real quick. Doing my best. That's the first one. That's the second one. Yeah? And I also know that this point right here is 4, 2. That's important, right? So when I'm solving this, what's the answer going to look like? Do we care about the x value or the y value? Yeah, what's the only variable in the equation, or the inequality? Only the x. So this right here is going to be super important, right? Because basically we're talking about a domain issue, aren't we? Okay? So what I want to know is the first part was the curvy part, right? And the second one is the straight line, this horizontal line. So when is the curvy part less than the straight line? Isn't all of this underneath the straight line? So what x value does that take into account? The 4, right? So it's everything less than 4, except you know rules about logarithms because you know rules about exponents. What happens right here? Why is there an asymptote there? Look. If I set this equal to 0, wouldn't I get a negative 5? Isn't there an asymptote at negative 5? So this also has to say greater than negative 5. Sorry. Because it's only between those two parts right there. You're right, it does not cross the asymptote over here, does it? Any questions about inequalities? Okay. So you have these 10 questions on the back. Notice which 10 I'm talking about. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know it says bonus, cross it out. Put required. Okay? But I also, please, would like you to do number 8 next to my bear attack. I would also like you to do number 10 and number 15. Okay? So you have 8, 10, and 15, and then you have the 10 on the back. Okay? So any of these ones here on the front, or in the middle that we did not circle, those are extra credit, right? Okay. Any questions? All right.